What is sorting? Suppose you have an array of values. You might want the array values to be ordered or arranged in some way. For example, you might want to order an array of numbers from lowest to highest, or from highest to lowest. Or you might want to arrange an array of strings into alphabetical order. Arranging a collection of items into a particular order is called sorting. So sorting is an ordering or arranging the array elements such that each element of the array is in a numerical, alphabetical, or some sort of order. Typically, we sort arrays into ascending or descending order. Ascending order is an ordering of the array elements from lower to higher order, and descending order is an ordering of the array elements from higher to lower order. Here are some examples on ordering. First is an ordering on numbers. So we assume that we have an array of type integer or double. Either we have an ascending order or descending order. In ascending order, every element in the array is smaller than or equal to the element that comes next to it. So 3 is less than or equal to 6. 6 is less than or equal to 11. 11 is less than or equal to 15, and we keep doing that until the end of the array. However, descending of these numbers is the opposite of ascending order, such that every element in the array is larger than or equal to the element next to it. So 30 is larger than or equal to 19. 19 is larger than or equal to 17, and we keep doing that until the end of the array. So we have 6 is greater than or equal to 3. So this is for a numerical order of arrays. If we have an array of a string, then the ordering is called alphabetical ordering. So in this case, we have to follow the alphabetical order for each string inside the array. For example, here, this is an ascending ordering. Apple in alphabetical order comes before banana. Banana in alphabetical order comes before mango. Mango in alphabetical order comes before orange. So we say that the array is in ascending order. Remember how strings are compared? They are compared by the ASCII code if it is in lexicographical ordering, or by letters if it is an alphabetical ordering. And also notice that in ASCII code, small letters and capital letters are not treated the same. But in an alphabetical order, small letters and capital letters are treated the same. So why apple comes before banana? The test is done by character by character. Now since A in alphabetical order comes before B, then apple comes before banana. Since B comes before M in alphabetical order, so banana comes before mango. So we don't look by the size for example, in numbers. In numbers, size is important. So if we have a number, that number of digits is larger than the other number, then definitely the number with the larger number of digits is larger. However, in strings, the length of the string is not used to determine the order of the string in the array. Sometimes a string with length larger than another string, but in terms of ordering, it is put in lower order. Therefore, the length of the string is not important when we come to order an array of strings. We've mentioned in the beginning that sorting is arranging each element of the array either in a numerical order or alphabetical order or some sort of other order. So what is the other sort of order? In this lecture, we are going to present a very simple sorting algorithm called selection sort. Although it is very simple and easy to understand, however, it is not the most efficient sorting algorithm in the literature. We are going to implement this algorithm on numbers, and if possibly, we will show you how to implement it on characters or strings. But the question is how to make it adapted to other sort of order. We can make minor changes to the sorting algorithm and make it adapted to sort arrays of values of any type that can be ordered. For example, we could sort an array of records or objects according to identification numbers, if these objects are objects of employees. Or we can order records or objects of students based on their GPAs. Or we can order employees based on their salaries, and so on. It depends on the data members inside the object. If the data inside the object can be ordered, then we can make minor changes to the sorting algorithm, make it adapted to this order. In the literature of algorithms, there are plenty of sorting algorithms available. Some of them are easy to understand, however, they are not efficient in terms of performance, and some of them are very efficient and they sort arrays very quickly, however, they are very complicated to understand. So it depends on the size of your array. If the size of your array is very large, then you have to pick a sorting algorithm that is efficient so that it gives you the result faster than the other ones. If your array size is very small, then it's better you implement it with a simple sorting algorithm because performance here is not a matter. In this presentation, we will show you an example of a sorting algorithm. It is called selection sort. Selection sort is a very simple sorting algorithm that we can apply it on small size arrays, but it is not the most efficient sorting algorithm as we have mentioned earlier. There are other sorting algorithms, to name some of them: quicksort, heap sort, bucket sort, insertion sort, bubble sort, and other sorting algorithms. Most of them depend on swapping or exchanging elements in the array. However, others are depending on dividing the array into smaller arrays and recursively sort each smaller arrays independently. When we say recursively here, it means that if the sorting algorithm is implemented as a method, then this method is calling itself. It is called recursion. We will study recursion later in this course, and a type of sorting algorithm that works this way is a quicksort and heap sort. These sorting algorithms are the most efficient sorting algorithms known up to date that are widely used in libraries, and Java is one of them. After we implement the selection sort, which is very simple to implement, we will present an experiment showing that sorting large arrays with selection sort is in fact inefficient and very slow, compared to a sorting algorithm that is implemented as a static method in a Java library that is available in Java, the tutel package. This static method is defined in the class arrays in the package java.util. So therefore, if you want to use it, you have to first import java.util.arrays, A in capital letter, and then in your program, you refer to the class name arrays.sort and you provide the array as an input parameter to this method. This is a Java class library that provides a very efficient sorting algorithm that can be used in your programs. We will show you later an example on how to use this package and how to use this sorting method for efficient sorting.